first thing first, I would like to introduce ourselves. We are Nusantara-AUV team from Indonesia, Department of Marine Science and Technology, Bogor Agricultural University. So, the technical overview that we want to share with you is specification first. Dimension of our AUV, 50 centimeters, 60 and 33. And the thrusters we use blue robotics, 6 thrusters, 200. The power we use 4 cells, lithium battery 5200. And for the camera we use webcam, and the casing or the chassis we use HDP, and we use system master slave with Raspberry Pi as master and Arduino as a slave. For the sensor we only use compass and depth sensor. Actually we have built the simplest AUV, simplest and a low cost one. Okay, next. For the mechanic, first we want to tell you about the mechanism of dropping the ball. We only create simple tube from PVC with the motor servo, as you can see in the layout. Okay. As you can see, we only use this simple motor servo with the ball inside the PVC tube. Before we ask the servo to moving, we keep the ball inside, and when we want to drop it, we make this servo has motion. So another mechanic is we use square shape of AUV because its stability in buoyancy, and as you can see this, 4 thrusters at the downside and 2 at the upside with this whole performance you can see. Next. Okay, the electronic. Because we only use very simple components, we use the battery controlling all of the components here. As you can see, camera, compass sensor, Raspberry Pi, Arduino, depth sensor, manipulator, thruster, and LED with Raspberry Pi and Arduino communicating each other. Raspberry Pi as a master and Arduino as a slave, or the executor. Raspberry will communicate with camera, compass, sensor, while Arduino will control manipulator, thruster, and LED. Okay, the technical overview next is about software. Overall software we only use Python 2.7. I know it's a little bit old, but it's okay. It's going well anyway. With the whole mechanism is this block diagrams. As you can see, start, we submerge, moving with certain direction, detecting object in a bucket and moving, and then drop the ball, detecting object, moving again, and then surfacing until the end. And another software is OpenCV. It is used for the camera to analyze the image color target. Okay, about the major challenges that we encountered. First, water type. We create underwater robotics, so the major problems is how the water not floating in. Then the stability of the compass. It is so essential because compass is so depends on what magnetic tools around it that may be bother and interference. And the third is image target recognition from the camera. Okay, how we overcame it. First, we want to tell you about the process that we have structure. Okay. About the structure. Okay, I'm sorry. First, we encountered difficulties how to decide what shape the AUV we will make. And we decided to have square shape, semi-square shape actually. First, it is easy to construct, and then two, is stability in buoyancy. Okay. A second is all about the buoyancy, it's ballast. I'll make it fast. Then the propulsion, about the thrusters, what type of the thrusters and how many thrusters we want to use. Electric power we use for cell-stable battery, 5200. About the control, you can see this. And the navigation. This picture describes when we did practice about 1 month ago. It is all about we control the direction of the AUV, and then the materials that we have talked about before, and other tools. And the last is about the handling. Okay, what I have learned from the last 5 days competition is first persistence, self-control, because we work as a team and we have so many members. Focus, discipline, respect, teamwork, creativity, and the most essential one is friendship. Besides, we improving our skills here. It is so much important to build friendship here with other participants here. And the last but not least, acknowledgement. Our sincere thanks goes to the SAUVC 2017 committees that have us here and have given us the opportunities to compete here. And then the Indonesian Embassy in Singapore, Ministry of Research, Technology and Higher Education, Ministry of Youth and Sports, and all of our friends in Agricultural University. Okay, that's all that we can share with you. Thank you.
Guys, any questions?
Yes.
You mentioned the manipulator block.
Yes.
In the diagram, can you explain the function of that block?
Which one?
Manipulator block. In the flow chart that you presented earlier. Yeah, here it's connected to the LED and ramp batteries. So
Yes.
the function of that block.
Question that.
What is it for? So the manipulator block, what is that for? What does that show?
Oh, this is about the communication amongst the components itself. So the relationship between one component to other components.
Why have your time are the LEDs just for your feedback and display, or do they serve any other function?
No, it's just about the figure of the communication only. Okay.
Is for display purposes?
Yes. Other question, please? Yes? Yes?
Sorry.
As far as I'm concerned, it's all about the timer. We have mistaken about the timer. We set the timer more off than it should be, and yeah, that's why we drop the ball not in the basket. Is there another question?
Participants, especially. All right, we have one
Yes.
right from the end. Yes.
What is the total cost of your robot?
The total cost not more than no, it's approximately less than 1,500, I guess. Singapore dollars. Yeah, approximately. Not more than that, I guess. Only for the AUV itself, right? Okay. So I think it's very low cost.
All right, thank you very much.
Thank you.
This is what is